It's your boy, Mr. AC. Alright, my friends, let's get this checking now. The function f is defined above. For what values of k is f continuous at 3? So here it is, right? Well, I provided a graph. It's not perfectly going to match to this, but I wanted to just illustrate something, which is this. So, number one, we have x plus 3. That's just a straight line. And this says, so when x cannot equal 3. Well, what is that telling us? That means x can be everything else but 3. That's why you see there's a hole right there, and it's everything else but 3. Well, how do we know the hole is located at this particular spot here? Well, really all you have to do is take 3, plug it in, and you get 3 plus 3, which is 6, right? So that means that when x is 3, right, we need to have a hole at 6, right? Because it told us that we cannot equal 3, but we can be everything else. And we have this value k. Right here, we have this value k. It's some random point on the graph. And what we're trying to ask is, well, what can we do to make this continuous? Well, to make this continuous, we want this open circle to be filled in. To illustrate that, here it is. Here's the same graph. What we want to do, okay, is we know at 6, it's not, when x equals 3, it's not continuous. The y value is 6. What we want is we want to take this random point, this random k value, and we want to fill it in. Boom. We want to be filled in. So now that point exists and the limit from the left from the right exists, and it's equal to that point there, right? So what does this point need to be? What does the y value need to be so that this is continuous? Well, it needs to be 6. So that's why over here we know then, oh, k has to equal 6, right? Because that's where the hole is. So we want this random point to fill it in, and that'll make the function continuous. So let's take a look at this graph here. So what's happening here is something like this, right? And this is why it's important to be able to identify how this graph looks like. So this is for as x is less than or equal to 2. So here's 2. I'm gonna put some random graph. So we know it's equal to, here's the point. When x is less than or equal to 2, we have some U shape, right? I don't know how it's gonna look like, but let's just say it's something like, it's supposed to look something like this, right? But we have to be equal to 2 or less than 2. So I don't know, maybe let's just draw something like this. This is probably not true, but I'm just trying to show you how I think of these. Over here we have k times x plus 2 when x is greater than 2. So when x is greater than 2, well, we need an open circle. When x is greater than 2, where's this straight line, right? Some straight line that's maybe looks something like this. I don't know. Okay, so this is a jump. Okay, and what we want to do is we want to take this green line, because this green line has the k value, and we want to find out what do we need to plug into k so that we can shift this up here and it can be nice and it can fill in like such, right? What we want to do is make it continuous. So we want to get this filled in points. We want them to be filled in. So what we want ideally is this right here. Let me go ahead and graph it down below here. What we want is this. Okay, we want to take this green line and move it up or move it down, however, so that it looks like this. So that way it's all filled in and the limit from the left and from the right equal each other, and we're continuous. Okay, so basically we want the y values from the left and from the right to equal each other. So what I like to do, okay, is let's take 2 here and let's plug it in into these functions to see, well, where is this open circle, this filled in circle located at? Well, we're going to get 2 squared minus 2 times 2 plus 8. We're going to get 4 minus 4 plus 8, which is equal to 8. So I know the y value should be 8. So we know right over here the y value should be 8. Okay, and where do we want this open circle? What do we want this y value to be? Well, we want it to be 8, right? So that it starts here and then we're like this. So first of all, let's take the 2 and let's plug it in for here, right? So we get k times 2 plus 2. In other words, this is 2k plus 2. And what do we want this whole thing to equal? Well, we want it to equal 8. We want the y value to be 8. We want the y values to be the same. So let's set it equal to 8. And let's just solve. Subtract 2 to both sides. You get 2k is equal to 6. Divide by 2. And you get k is equal to 3. And there it is. Okay, and that makes sense. If you put 3 in here, so 3k plus 2, and you take 2 and you plug it in, well, take 2, what's 3 times 2 plus 2 is 6 plus 2, which is 8. So we know we got the same y values from the left and from the right, okay? And this problems, we're trying to make a function continuous. So let's take a look at this one here. The function f is defined above. For what values of, this should say b, my apologies, because I have b there. For what values of b is f continuous at x equals 2? Okay, well, first thing that we want to do in this problem is let's identify how this graph looks like, okay? So here's 2. Well, this is saying that we can be everything else except for 2. Okay, so that means at 2 we should get some hole and we can be everything else. I don't know how it's gonna look like, so I'm just gonna make it look like this, okay? Because I don't have a perfect image of how this will look like. Maybe it's a straight line, maybe it's not. I don't know. That it doesn't matter to me. I just want to know how will it look like. And here we have when x equals 2, well, we have some y value, right? So we have some y value, right? I don't know. It could be anywhere along the line. And what we want to do is like the problem up above. We want to make it continuous. So we want this y value to be here, and we want it to fill in this hole wherever this y value is located at. Well, that's our first step. Let's find out where is the y value located at, right? Well, how do we do that? Well, we know the hole is going to occur when x is equal to 2 because it doesn't exist there. So plug in 2 to your function. But before I do, I might want to factor the numerator just to make this problem a little bit easier for me. And I think I'm going to get x. Well, what two numbers multiply to give me 12 but add to give me -1? I believe this is x minus 4, x plus 3. Notice I wanted to just factor it first. Well, now these cancel and I'm left with x plus 3 over b, okay? Well, now I'm going to take my 2 and I'm going to plug it in. In this case, I'll plug it into the x case. It's nicely simplified. 2 plus 3 is 5. And we got over b. So I like to put that whenever I get my y value, that means this is 5 over b. And I'm going to write that maybe in a darker color so that we could see it. This is 5 over b. Okay. Well, now, can we plug 2 into here? No, there's no x value, right? So we know this is over here. This is just b right there. So what do we want? Well, we want these y values to be the same. Just like the example problem above, we wanted them to be 8, 8. In this case, what do we want them to be? Well, we want them equal to each other, right? We don't know what it is, but we want them equal to. So we're just going to set them equal to each other like such. 5 over b is equal to b. And let's solve for b. Well, if I want to get rid of the b from the denominator, so let's multiply b to both sides. These cancel, and I get 5 is equal to b squared. Now I'll take the square root, and we get b is equal to the square root of 5, but don't forget we need to have a plus or minus. So the plus or minus is going to go there. So that means if this is the value of b, that can make this function continuous. The plus square root of 5 and negative square root of 5. Well, the function f is for what values of b is f continuous? Well, we know it's at -5 and the square root of 5. And I end up that right here. 1 and 2 both make f continuous at 2. Don't worry about the lettering. I made this problem and I kind of messed up this letter. It should be number 5. Well, 1 and 2, right? The negative square root of 5 and positive square root of 5. Okay. I think we're slowly getting the hang of these. Those are the only three problems I wanted to go over, and hopefully you'll get a little bit of practice and this will make a little bit of more sense. Take care.